Hello and welcome class. So in last class we have studied about what is frequency, wavelength, different characteristics of sound which include loudness, pitch, amplitude, quality of sound, tone and note. Today we will start solving some NCERT questions related to that, and after that we will continue this chapter. So let's begin by solving some problem. And question number 1 asks you that which wave property determine loudness, and B part is pitch. So which property of the sound wave determines loudness? How loud a sound wave is determined by the amplitude of the sound. Higher the amplitude, louder will be the sound. So loudness is determined by amplitude. And what is pitch? Pitch is how our brain unable to determine between two different frequencies. So pitch is determined by frequency. So correct answer is loudness is determined by amplitude and pitch is determined by frequency. The detailed answer is amplitude. The loudness of the sound and its amplitude is directly related to each other. Louder will be the sound if the amplitude is large. Clear class? And frequency, the pitch of the sound and frequency are directly related to each other. If pitch is higher, frequency is higher. If pitch is low, frequency is low. So loudness is determined by amplitude and pitch is determined by the frequency. I hope this answer is clear to you. Now let's move to next question, question number 2. Question number 2 is guess which sound has higher pitch? Guitar or Carn horn? According to you, which will have higher pitch? A guitar or a Carn horn? What is higher pitch? Higher pitch means higher frequency. Higher pitch means higher frequency. So which will have higher pitch? A guitar or a car horn? And the correct answer is pitch is directly proportional to frequency. Higher the frequency, higher the pitch. So guitar will have higher pitch. We know that the car horn sound is loud. Car horn sound is loud, but it does not implies that it has higher frequency. Guitar has higher frequency. So guitar will have higher pitch. Car horn has high amplitude. So car horn is loud, but guitar has high pitch. The speed of sound is defined as distance which a point on a wave such as compression and rarefaction travels per unit time. This is the definition of speed of sound, that how much distance the wave cover in a given time is called the speed of sound. And speed is equal to distance divided by time. Okay, and distance is here wavelength and time is time period of the wave. So this is the formula of speed of sound. Clear class? So V equals to lambda T, and we also know that frequency is equal to lambda divided by T. And frequency is known as 1 upon time period. So speed will be equals to lambda nu. This is the formula for speed of sound. Clear class? This is the formula of speed of sound, which is equal to multiplication of wavelength into frequency. Okay, V is equal to lambda nu. So speed is equal to multiplication of wavelength and frequency. The speed of sound remain almost same for all frequencies. In a given medium, if you don't change the medium, the speed of sound remains the same. And whenever you change the medium, after changing the medium, frequency will remain same but the wavelength changes, and if wavelength changes, the speed also change. Let's solve another example. A sound wave has frequency. A sound wave has frequency nu equals to 2 kilohertz, or kilo means 1000. So 2 into 1000 hertz, or 2000 hertz, and wavelength 35 centimeter. Wavelength symbol is lambda. Lambda is 35 centimeter. We have to convert it in meter, and 1 centimeter is 1 by 100 meter, or 0.35 meter is the wavelength. How long will it take to travel 1.5 kilometer? We have to calculate how much time period this wave will take to travel 1.5 kilometer. How are you going to solve this problem? Frequency is 2000 hertz, wavelength is 0.35 centimeter. We have to calculate how much time this wave will take to travel 1.5 kilometers. And how we can calculate it? To solve this, we have to first calculate what is the speed of sound. First, calculate. Step first, calculate velocity. Now, second step, we know that velocity is equal to distance divided by time. We know the velocity, distance d is given to us 1.5 kilometers. We can calculate the time. Yes, we can calculate the time by using these two equations. First, calculate velocity. And how you going to calculate velocity or speed of sound? Speed of sound is equal to lambda times nu. So first, we will calculate the speed of sound. We know the speed of sound, we know the distance, we will calculate the time. You can convert this distance into meters. So 1.5 into 1000 meter, which is equal to 1500 meter, is the distance. Now you can calculate the time. Is it clear, class? So first we will calculate. So frequency is 2000 hertz, wavelength is 0.35 meter. First we will calculate the velocity or speed of the sound, which is wavelength into frequency, which comes out to be 700 meter per second. Is it clear to you? First step is to calculate the speed of sound. And what is the formula of speed of sound? Speed of sound is wavelength into frequency. Now we have to calculate the time period. We know that speed is equals to distance divided by time. What is the distance? Distance is 1500 meter. We have to calculate the time. And what is the velocity? Velocity is 700 meters. Now change these position. So 1500 meter per second divided by 700 meter per second, meters. is equals to time period, and when you will solve these, cancel. 15 divided by 7 is equal to 2.1 second. So if a wave which has wavelength of 0.35 meter and frequency of 2000 hertz will take 2.1 second to travel 1.5 kilometers. Is this question clear to you? Very good, class. Now we will move forward. Next question is, what are wavelength, frequency, time period and amplitude of sound wave? So we have to define what is wavelength, what is frequency, what is time period and what is amplitude of a sound wave. So let's plot a curve. This is distance and this is density. And let's suppose this is the sound wave. This is two crusts, and we know that the distance between two crusts is known, two consecutive crusts is known as wavelength. Okay, what is frequency? If this is one oscillation, okay, if this is one oscillation, then the number of oscillation per unit time is called as frequency. What is time period? The time taken by two consecutive crust or two consecutive trough to pass through one fixed point is known as time period. And what is the amplitude? Amplitude is the maximum distance from mean position of the particle is called as amplitude. So I think from this curve, all four definition is clear. Okay. Wavelength can be defined as the distance between two consecutive crust or trough or two consecutive rarefaction or two consecutive compression. Its symbol is lambda. Its SI unit is in meter, which is represented by small m. Frequency is defined as number of oscillation per second. Its symbol is nu and its SI unit is hertz, represented by capital H, small z. What is amplitude? Amplitude can be defined as maximum distance or maximum height reaches by trough or crest of a sound wave. And what is time period? Time period is defined as the time required to produce one complete cycle of a sound wave. Time taken by one complete cycle is known as time period. I hope all four definitions are clear to you. Next question is, how are the wavelength and frequency of sound wave related to speed? So what is the formula which relate speed, wavelength and frequency of sound wave? And we know that speed is equals to wavelength into frequency. This is the formula which relates wavelength, frequency and speed of sound wave. The correct answer is speed is equal to wavelength times frequency. V equals to lambda nu. Okay, where lambda is the symbol of wavelength and nu is the symbol of frequency. Question number 3. Calculate the wavelength of sound wave whose frequency is 220 hertz and speed is 440 meter per second in a given medium. So we have to calculate wavelength. We have to calculate wavelength whose frequency nu is given as 220 hertz and speed v is given as 440 meter per second. So how you going to calculate the wavelength if speed and frequency is given? Okay, this is find given. What will be the formula used? Formula used will be speed is equals to frequency into wavelength. V is equals to nu lambda. Okay, you will put the value of speed and frequency and find out what will be the wavelength. Frequency is given, speed is given. We can calculate the wavelength using this formula. Speed is equals to wavelength time frequency. Okay. And when you will solve it, wavelength will be 2 meter. Clear class? Because the unit of speed was meter per second and unit of frequency was in hertz, so wavelength will be in meter. So correct answer is the wavelength of sound is 2 meters. Question number 4. A person is listening to a tone. A tone means a single frequency, and the frequency is 500 hertz, sitting at a distance of 450 meter from the sound. What is the time interval between successive compression from the source? Very nice question. A person is listening to a tone of frequency 500 hertz, sitting at a distance of 450 meters. We have to calculate the time interval. How are you going to solve this problem? So the answer is the time interval between two successive compression from the source is equal to time period, and the time period is reciprocal of frequency. So time period is 1 upon frequency, or 1 upon, sometimes we wrote frequency as f. Time period is equals to 1 upon 500. So time period will be 0.002 second. This will be the time period. Now the amount of source energy passing each second through unit area is, this is new topic. From here the question is completed. Okay, we have calculated the time period, and in this formula the number of oscillation is 1 because in question it is given as that person is listening a tone. So number of oscillation is 1. Frequency is already given. We do not need to use the distance. Now we are learning a new definition which is called intensity of sound. And what is intensity of sound? The amount of sound energy passing each second through an unit area. Energy divided by area into time is known as intensity. How much sound energy is passing through an area per second is called as the intensity of sound. We sometimes use the term loudness and intensity interchangeable, but they are not same. We sometimes say the sound is loud. We sometimes say the intensity of sound is loud, and we interpret these two words like same, but they are not same. Loudness is the measurement of how much higher the intensity is or how much energy we are giving to uh, to that sound wave, or loudness is a measurement of the response of our ear of sound, how our ear respond. If a voice is loud, we close our ear so that those waves don't reach our eardrum. Okay, so loudness is a measurement of the response of the ear to the sound. Even when two sound are of equal intensity, if two sound have equal intensity, but there may be case that one may be louder than other because our ear detects it better. Now let's distinguish between what is loudness and what is intensity of sound. So intensity of sound is energy passed through an area in every second. Energy divided by area per unit second is called the intensity, where loudness is the how much amplitude a sound wave have is called loudness. Clear, class? Now we have completed one important topic, that was characteristic of the sound. Now we are starting a different topic, and our next topic is speed of sound in different medium. We know the formula of speed of sound. Speed is equals to wave wavelength into frequency. This is the formula of speed of sound. Now understand one thing, that frequency never changes. Frequency does not change. Wavelength changes. And if wavelength changes when we change the medium. Okay, class. So frequency never change, but wavelength changes when we change the medium, and when wavelength changes, speed is also changed. And we know that medium are of three type. What are those type? One is solid, one is solid, one is liquid, and last one is gas. Okay, in solid, the particles are close. In liquid, particles are little bit far away. In gas, particles are very much far away. Okay, and how sound propagates? Sound propagates through vibration. Vibration propagate, and that propagation of vibration is called the propagation of sound. Now let assume this particle is close to a sound source and it start vibrating. It will pass its vibration to this one particle, come to rest, and this one particle will pass its vibration to other particle, and these two particle will be in rest, and that's how this series will continue um, till that those vibration don't reach our ear. In liquid also same phenomena will happen, and in gas also same phenomena will happen, but there is one catch, that in solid particles are close, in liquid particles are little bit far away, and gas particle are very much far away. So according to you, which one will take more time to pass its vibration? In which medium particle will take more time to pass its vibration? And your answer will be gas, because particles are far away. If this particle is vibrating and this wants its vibration to pass to this one particle, it will take longer time in comparison to solid. So, and the propagation of vibration is the propagation of sound. And in this one, in solid, it is happening in very fast speed. So the speed of sound is fast in solid. Speed in solid is greater than speed in liquid, and speed in liquid is greater than speed in gas. So in gas, the speed of sound is lowest because particles are far away from each other. Clear, class? So in next class, we will again start the topic speed of sound in different medium, and we will learn what is the speed of sound in solid, liquid and gas, and we will discuss it more further. I hope today's class is clear to all of you. Thank you so much.